dry ice and put it on the table, and take a piece of dry ice and put it in water, the same exact thing is happening.
It's because since the water is too warm to dry ice,
it's room temperature. The water is the same temperature as the air. So what is happening differently to the dry ice in the water that's not happening to the dry ice on the table?
That water is freezing.
Does anybody know?
This one's melting a lot faster.
It's melting a lot faster, but
Is that
why?
cold?
Because the temperature of that water was the same as the temperature of the air. But obviously the dry ice is behaving. The dry ice is behaving differently in the water. Does anybody know?
Oh, because it's in liquid.
Stop.
Because it's in liquid. But what causes it to boil off faster or to melt faster?
Because the dry ice is not nuclear bomb. Had the experience of turning into a liquid, so it is that.
Well, the dry ice is constantly turning into a gas on a table, but it's also turning a gas in the water, but faster. Why is it doing it faster in water?
Because you kidding me? That's not cold. The water's cold. Is it?
Not quite.
Touch the water.
Okay, let me ask you another question, guys.
That's not cold. You touched it? Yeah.
Is air or water more dense?
Water.
Oh, water.
Water's more dense. So water's thicker than air. And because water's so much more dense than air, when we put dry ice in water, there's more water molecules in contact with the dry ice, and it's transferring the heat to dry ice very quickly. Where gas is not very dense, and the contact of the atoms of the gases in the air with the dry ice is much less than the contact of water with the dry ice, because it's much more dense. So therefore the water has a much greater chance of transferring heat to the dry ice and accelerating the process of sublimation. So it's forming gas much more rapidly in water, and that's why it looks like it's boiling in room temperature water. What's happening is that process of sublimation is sped up. So that's actually what's happening.